Alright, so next we are going to talk about the Faraday's laws of electromagnetic induction. There are two laws, and before going to discuss the two laws, we have to conclude what are the things which we found out from Faraday's experiment, or which we understood from Faraday's experiment, that we have to initially we have to analyze those values. I mean those things. Alright. So first thing we have got it, that is Faraday said from the first experiment itself, whenever there is a magnetic flux linked with a closed coil changes an EMF. What is EMF? Electromotive force. We have seen that in current electricity is induced, and hence the electric current flows through the circuit. Okay, so due to that induced EMF, induced current is flowing through the circuit. So this current is called an induced current, and the EMF induced, that is called as induced EMF. Okay, and this phenomenon is known as electromagnetic induction. So what that thing is very clear, that is whenever there is a change in magnetic flux linked with a circuit, I mean a coil, then there will be an induced current or an induced EMF. Okay, now we have to take care, we have to care what are the other things from Faraday's experiment we have noted. Okay, and let's talk about those things actually. And first thing, I would like to show you the picture here. Okay, you can check that. So here, right deflection. First we will discuss about right deflection. If a magnet is deflecting, or if the magnet is moving towards the right direction, then what would happen? If the magnetic, when you take it from the initial side, that is the magnetic flux linked with the circuit is less. That is, magnetic flux is less, then what will happen? The deflection will be less. Okay, when you try to move inside, more flux will be linked with the coil. Look at this, when you move towards this direction or coil to this direction, then more flux will be linked with the circuit. Okay, in that case, what will happen? More deflection will happen. Alright, so second one, left deflection is also same, but in the opposite direction. Initially, the flux linked with the circuit is more, and when you take it out, then what will happen? The flux linked with the circuit will be less, or it will be reducing, gradually reducing. But even it is reducing or increasing, there is a change is happening. Flux linked with the circuit is changing. That is what is the major thing about electromagnetic induction. You have to think like that. What is flux? I have already explained what is flux. Okay, you can connect field and flux. Okay, then it will be easy. Okay, so that is the first thing. And second, the same idea, that is the same thing which is given, that is with the two coil experiment. That is, Faraday also had done two coil experiment, and in one coil, the flux linked with the one coil is increasing when it approaches to the other coil, and it is decreasing when it is going away from the other coil. Okay, so you can check the picture that I have given here. You can check them. Okay, so this is what is the major thing. Okay, two major things we have explained. Then Faraday concluded by using these results, that is, what are the laws which had given by Faraday. First law, what is the first law? Whenever there is a magnetic flux leakage, or whenever there is a change in magnetic flux associated or linked with a coil or a circuit, then what will happen? Then EMF is induced in the circuit. Okay, so why does it close the circuit? Because, for example, I would like to give you an example. This is a very important thing, that is in upcoming classes also I would ask you the same question. This is a circuit and this is a magnet, north to south. When it comes towards this circuit, how much current it will induce, or which direction current will induce? There will be question like many questions. Okay, direction and all you will study, lengths law you will study, don't worry about that. But my question is, how much or what will be the direction, or any question you could ask. But you can say that no induced current or voltage. You can easily write no induced current, no voltage. This question you can expect in the board exam. So what is the answer? No induced current or no EMF. Why? Because the circuit is not closed. Alright. So then What about the second law? Second law, the magnitude of induced EMF in the closed circuit is equal to the rate of change of, actually time rate of change is not needed actually, so it's a rate of change of. According to our textbook, it is time rate of change of, but it is enough. Rate of change of is enough. Rate of change of magnetic flux linked with the circuit. Okay, so what is EMF? EMF is equal to rate of change of. Wait, I'll explain. Okay, we need the mathematical formula for the second. Okay, first law does not have any mathematical formula or mathematical explanation, or it is a phenomenon, right? So Faraday explained that phenomenon through the first law. Second law, it is equal to. So what is the EMF? EMF E is equal to. It is the rate of change of d phi b divided by dt minus sign. So why does this minus sign? I'll explain it later. That is what is Lenz's law says. So that is what Lenz's law says. So E is equal to minus d phi b divided by dt. Rate of change of, I would like to write it as rate of change of magnetic flux. Magnetic flux. Or also I can write it as, if there are n number of coils, we have been using a coil like this. So suppose n number of coils are there, then I can write E is equal to minus n into d phi b divided by dt. d phi b divided by dt. Or I can write it as, this is also I can write it as, this n is a constant, so I can take it inside. So minus d by dt of, you all know that it is n into phi b. So I can easily take n inside, because suppose 5x, d by dx of dx by dt of into 5, you can write d by dt of 5x, no problem. So then this n into phi b, this is very important. This is known as flux linkage. This is known as flux linkage of the circuit or the coil. Flux linkage of the coil. This is very important. Flux linkage of the coil. So n into phi b. So that n is the number of coil into phi b. That is a magnetic flux associated with that coil. So n into phi b. So this is what is the Faraday's laws. So I think you got it. So you, if you haven't got it, you watch it again, because Faraday's laws are very important. And next we will discuss. So the next question arises: why this minus sign? Why this minus sign? So that you will get in the next video. I mean the next topic. We have to discuss about Lenz's law, and before that, before going to discuss about Lenz's law, we have to solve some problems regarding Faraday's laws of electromagnetic induction, and after that we will discuss about it. Okay, thank you.